presentation of interfacing LEDs with Raspberry Pi. Raspberry Pi is a single board computer, and generally the peripheral devices are connected with the help of GPIO or general purpose input output pins. In LEDs, there are two methods of connecting. One way is to connect the GPIO output to the anode of the LED or to connect the GPIO output to the cathode of the LED. Accordingly, the LED can be active high or active low. To control these LEDs, making them on and off, we have to write programs using Python. Raspberry Pi comes with Raspberry operating system, and in this operating system, we have to select the Python 3, the IDLE, that is Integrated Development Learning Environment, available in Raspberry operating system. To control these LEDs, the program should have certain steps. Firstly, we should import the GPIO library. Then we should select which numbering system we have to use, whether the Broadcom numbering system or the physical numbering system. Wherever LED is connected, that GPIO pin has to be set as an output pin. To make it on or off, we have to send a logic level 0 or 1 to that LED. And finally, we should clean up the resources and bring back the GPIO pins to the default conditions. All these steps are written in the form of Python statements in any Python program. So for example, if we consider to make a LED on, in case of common cathode, we have to send a logic 1 to make it on, which is sent by sending a digital state true to LED connected to pin number 14. Similarly, to make a LED on in case of common anode, we have to send a logic 0, which is sent by sending a digital state false to the output of LED connected to GPIO pin number 14. To make the LED off, exactly opposite state has to be sent. That is false or logic 0 in common cathode and digital state true or logic 1 in case of common anode. Instead of just interfacing one LED, we can also interface 8 LEDs to different GPIO pins. In this example, the 8 LEDs are connected to these consecutive GPIO pins. Each GPIO pin also has a hardware pin number, and it is the user's or the programmer's choice to select the numbering system to be used. To control these LEDs, we can consider different examples. One is simple on and off. Second is blinking, where the LEDs are made on and off with some time delay continuously. In a ring counter, the LEDs are made on one after the other, remaining LEDs are made off. And in up counter, the output is sent in such a way that the LEDs demonstrate a state in the increasing order. This is a Raspberry Pi board, and these are different LEDs. The GPIO pins are connected to these LEDs, and by sending appropriate states, the LEDs are made off. The upper LEDs are arranged in a linear fashion, and they are common anode type of connection. Here, logic 0 is sent through the GPIO pins to make the LEDs on. The lower LEDs are arranged in a circular fashion, and they are common cathode type of connection. A logic 1 is sent to make the LEDs on. In case of blinking, these LEDs are made on and off continuously with some time delay. In a ring counter, the LEDs are made one by one, and remaining LEDs are off. And to demonstrate up counter, we use the LEDs of a 7-segment display, and the state goes on increasing, and the display shows us numbers from 0 to 9. So this is how we can interface LEDs with Raspberry Pi and control them using program in Python. So I hope you have understood these basics of Python programming. Thank you very much.